Welcome. Today we're going to talk about graphing inequalities on a number line. We'll also mention how to graph compound inequalities. So when I work with graphing something like x is greater than -7, because it does not include the or equal to symbol, I am not going to have a filled in circle. I'm going to have an open circle over the number I'm comparing it to. For example, -7. I'm going to put an open circle over the -7. Now, the direction that you should draw your line, please notice, if the direction of the variable is on the left-hand side of the inequality, then you are going to follow whatever direction the inequality is pointing. In this case, to the right. I strongly urge you to always include a number on either side of the number you're working with. So -7, I could put -10 and +2, for example. It does not have to be equidistant from it. I don't care whether it's -10 and +2000, as long as you've got an accurate number on either side to say that there's a number on this side and a number on that side, and they're in the right place, so that I know you know which direction it's going. Secondly, if you're not sure which it is and the variable's not on the left-hand side, you can always take the number and plug it in for the variable. Is 2 greater than -7? If the answer is yes, it goes in that direction. If it's no, it should be going in the other direction. All right, so let's take a look at this next one. 4, a number below like 0, a number above like 10, and then we have to graph it. Because it has or equal to, I'm going to put a solid dot over it, and then a line. 0 is smaller than 4, so it is going to the left. Finally, I've got 0, so I can pick a number on either side, like -1 and +1. And then it's an open circle with an arrow to the left. -1 is definitely smaller than 0. +1 is not smaller than 0, so you can be sure you've done it right. So that's graphing inequalities that are already solved. The other day we solved inequalities. This is graphing them. So now if you are working with compound inequalities, and you'll see what they look like here, if it's got an or, if it is in either graph, it's in the or graph. You'll see what I mean in a minute. For an and, it has to be in both graphs to be in the and graph. So now, if you were trying to do a logic statement for an or graph, it only has to be, it's true if even just one of the things is true for an or graph. For example, I am a math teacher, or I'm 7 feet tall. Well, I don't know if you know me, I am not 7 feet tall. So, I am a math teacher, I will tell you that much so far. And so, I know that at least one of those is true, so that it's definitely a true statement. With and, both pieces have to be true. I went to the store and I went to the bank. If I only went to the store and didn't go to the bank, that's a false statement. But if I went to both the store and the bank, then it's a true statement. So it has to be both. In other words, where the two graphs overlap only for an and. Let's take a look at 3 different situations for or. The first situation is x is less than or equal to -2, or x is greater than 7. Now, all the graphs I use in this example and the next 5 examples are set up in this same way with -2 and +7, just to be consistent. It's not that it always is going to be like that, but I used it so that it was consistent. The first graph is of the first inequality. X is less than or equal to -2. Solid dot over -2, arrow to the left. The second graph that I'm going to make is of x greater than 7, which is my second inequality. Open circle over 7, arrow to the right. The OR graph is where these two graphs are in the problem. Let me show you what I mean by that. If I were to push both of these down onto this graph, that would be your OR graph. It's in below -2 and equal to -2 is in at least one of the graphs. Above 7 but not equal to 7 is in at least one of the graphs. So therefore, your OR graph is whatever is in either graph together. Let's see, I want this, so it's not behaving. There we go, hopefully. Solid dot over -2, arrow to the left. Open circle over 7, arrow to the right. That is my final answer here, and I don't know how that changed to green. It must have been highlighted. This whole thing should be, no, not all that. Giving me trouble. Let me fix it. Should be blue. There, that's better. All right, so there it is. That's your answer graph. This is like your scrap work. This is your answer graph. Do you have to do these two graphs? No, you don't have to do those two graphs. But just like in solving an equation, showing the work is helpful. And it can help you, not just me. All right, here's our next example. Almost the same, I only changed the inequality for this one. X greater than or equal to -2 or x greater than 7. So I've got a solid dot over -2, arrow to the right in this case. Let's see, open circle over 7, arrow to the right. Please notice they both go to the right. It's not where they overlap, it's if it's in either one. So if I bring this down like this, can you see how that line just flattens right over that open circle and fills it right in? So it's in, -2 is in the graph, above, between -2 and 7. 7 itself in the red line is in the graph, and both of them are above 7. So our final answer in this situation is a solid dot over -2, arrow to the right. Now, can you see that green is lit up and it came out blue? I don't understand. Let me see if I can fix that. There we go. There's your final answer. Next one. Now I not only have this one greater than, this one is now less than. So I'm going to put a, it's red, come on, it's red. A solid dot over -2, arrow to the right. And an open circle over 7, arrow to the left, not right, left. Let me just erase what I've mistaken, that's better. Now, these go in both directions and they overlap. So if I were thinking about this, is below -2 in at least one graph? Yes. Is -2 in at least one graph? It's in both of them. Between -2 and 7 is in at least one of the graphs. Yes. 7 is in this graph, but it's not this one. So it only has to be in one to be in the answer. Yes. Above 7, yes, it's in one of the graphs. So truly, all of this is in the graph. And another way of saying that, this is the correct way to graph it, all real numbers. That is the answer. So the three types of graphs for an OR are Starting in two spots, going opposite directions but overlapping, that gives you all real numbers. Starting in two spots going in opposite directions, that graph is just what I stated. And then if they're both going in the same direction, it's just one direction from the furthest back or forward, whichever, from the longest line, let's say it that way. So like this was the longer line than that one, so it's going to be that line. Okay. And graphs. Here's our first and graph. Let us graph the first inequality. Again, it's a solid dot over -2, in this case arrow to the left. X greater than 7 is an open circle with 7, arrow to the right. Where do these two overlap? If you remember Venn diagrams, two circles that overlap. If you remember back in elementary school days, you'd have one circle that was blue, one circle that was red, and when they overlapped, wherever that was, it was purple. Well, we want the purple. So where do these things overlap? They don't. There's no overlap here. So therefore, no solution. And you don't even draw a graph for it because you can't. There's nothing there. The next example I've changed slightly with one of the inequalities. So I've got a solid dot arrow to the right this time. Again, they're both in the same direction, open circle, arrow to the right. They only overlap from here that way. In fact, if I move this up so you can compare it, you can see the only overlap is above 7. I'll move that back. So therefore, when I go to graph the and graph, the answer graph, it does not include 7 because that's not in both. It has to be in both graphs, but above 7 is in both graphs. Our final graph, this is one way to write it, and I'm going to show you why that is another way to write it in a minute. So I'm going to graph -2 greater than or equal to, x is greater than or equal to -2. I'm going to graph x is less than 7. Where do these overlap? Well, if I were to take this line and put it right at -2, and this line and put it right at 7, now this is going to be a visual way to see where they overlap. There are 3 sections of this graph. There's below -2, there's between -2 and 7, and then there's above 7. So the question you should ask yourself is, are both graphs below -2? The answer is no, only one of them is. Are both graphs above 7? No, only one of them is. Are both graphs between -2 and 7? The answer is yes. So we're definitely going to have a graph going in here. Now, how do I do the ends of that graph? The endpoints. 7 is in this graph, but it's not in this graph. Because remember, that open circle is like falling through a trap door. It's an open hole. There's nothing there. So that does not include 7. This does. So I am going to include that open circle saying there's no 7 there. The solid dot and the line both mean that that point is there. And so -2 is here and here. So therefore it's a solid dot to say that it includes -2. So it's between -2 and 7. It does include -2, but not 7. That's what this says. It is x is between -2 and 7, and it includes -2. So you are going to see occasions where it's written this way, and other times where it's written this way. Both are both of these are and situations. This is our final graph. This is represented here, so is this. And that is all there is to it. I hope it was clear. Have a great day.